Dear students, in this video session we shall see how to solve an unbalanced transportation problem. Now consider the transportation problem in which there are three factories F1, F2 and F3 from which the items can be transported to the various stores A, B, C and D. It is given that factory F1 has 30 items, factory F2 has 40 items and factory F3 has 30 items. Summing up, we get the total available resources as 100. The store A requires 20 items, store B requires 20 items, store C requires 25 items and store D requires 30 items. Therefore, the total requirements for the stores A, B, C and D will be 95. Here, the total requirements does not match with the total available resources. This kind of transportation problem are called unbalanced transportation problems. To solve this problem, the number of available resources must be equal to the total number of requirements. To balance, we need to introduce one more store, say E, whose requirement is 5. So insert one more column called as dummy column for the store E. This column is called dummy because the store E does not exist in reality. Introduce 5 as a requirement for the dummy store E. Now we find that the total available resources is same as that of the total requirements. Since store E is represented by dummy column, let the unit cost of transportation be taken as 0 everywhere in this column. As usual, represent the given problem by placing the unit cost of transportation on one corner of the cell. We shall find the initial basic feasible solution by Ogle's approximation method. For this, we shall calculate the penalties. P1 is the first penalty. The least unit cost of transportation in F1 row is 0 and the next highest is 7. Therefore, P1 is 7 for F1. Similarly, P1 is 6 for F2 and P1 is 5 for F3. The least cost of transportation in column A is 5 and the next highest is 7. Therefore, P1 is 2 for column A. Similarly, P1 is 2 for column B, 2 for column C, 2 for column D and 0 for column E. Among all penalties P1, 7 is the highest. Choose F1 row corresponding to the penalty 7. In this row, choose the least cost cell. Now it is 5 requirements versus 30 availabilities. Now allocate 5 in the chosen cell. That is, factory F1 sends 5 items to fulfill the requirement of 5 in the dummy store E, and the factory F1 is left with 25 items and no more requirements in the dummy store E. Since all the requirements are fulfilled in column E, no more allocations are possible in this column and therefore block this column and calculate further. Now find the second penalty. Among the penalties P2, the highest penalty is 3. Choose the F3 row corresponding to the penalty 3. Then in F3 row, choose the lowest unit cost of transportation. Note that 0 is already blocked, so choose the least among 5, 8, 15 and 9. Therefore, we choose the cell having 5. Now it is 20 requirements in store A versus 30 availabilities in factory F3. So, allocate the chosen cell with 20 so that all the requirements of store A is fulfilled by sending 20 items from the factory F3. So, no more requirements in store A and hence block the column A, and 10 more items are left out in the factory F3. Calculate the next penalty P3. Now, among all the penalties P3, the highest penalty is 5. Choose the F2 row corresponding to penalty 5. Among 11, 12 and 6, the least cost of transportation is 6. So, choose the cell containing 6. Now, it is 30 requirements in store D versus 40 available in the factory F2. So, allocate this cell with 30 so that all the requirements of store D is fulfilled and 10 more items is available in the factory F2. Since there is no more requirements in store D, block column D. Now, calculate penalty P4. 7 is the highest penalty among P4. Choose the F3 row corresponding to penalty 7. Among 8 and 15, the least cost of transportation is 8. Therefore, choose the cell containing 8. Now, it is 20 requirements in store B versus 10 available in the factory F3. Allocate 10 in this cell so that there is no more available items in factory F3 and 10 more is required in the store B. Now, block F3 as there is no more items are available in the factory F3. Calculate the penalty P5. Amongst P5, the highest penalty is 4. Choose the F1 row corresponding to the penalty 4. Among 10, 14, the least cost of transportation is 10. So, choose this cell for allocation. Now, it is 10 requirements in store B versus 25 available in the factory F1. So, allocate 10 from the factory F1. There is no more requirements in store B and hence block column B. Now, 15 and 10 items are available respectively in the factory F1 and F2, but store C requires exactly 25. So, allocate these values in the left out cells. Now, we find that all the resources are distributed to fulfill all the requirements. Hence, this gives the initial basic feasible solution by Ogle's approximation method. Therefore, the total cost as per the initial basic feasible solution is 790. It does not know whether rupees 790 is the optimum cost of transportation for a given problem. Now, we shall verify that. We consider a new table by replacing all the occupied cells by star. Also, we find that the number of occupied cells is 7 and is same as the number of rows 3 plus number of columns, that is 5 minus 1. Therefore, we can check for the optimality. Now, based on the occupied cells, we have to find temporarily a split of the unit cost as U's and V's. Let U1, U2, U3 with the values of U's for F1, F2 and F3 respectively. Also let V1, V2, V3, V4 and V5 with the values of V's for A, B, C, D and E respectively. Let U1 be is equal to 0, then V2 is equal to 10, V3 is equal to 14, V5 is equal to 0. Based on V2 is equal to 10, U3 is equal to minus 2. Based on V3 is equal to 14, U2 is equal to minus 2. Based on U3 is equal to minus 2, V1 is equal to 7. Based on U2 is equal to minus 2, V4 is equal to 8. Now we find the sum of U's and V's in the unoccupied cell and subtract the unit cost of transportation. Therefore, for row F1 and column A, 7 plus 0 minus 7 is equal to 0. For row F1 and column D, 8 plus 0 minus 8 is equal to 0. For row F2 and column A, 7 plus of minus 2 minus 7 is equal to minus 2. For row F2 and column B, 10 plus of minus 2 minus 11 is equal to minus 3. For row F2 and column E, 0 plus of minus 2 is equal to minus 2. For row F3 and column C, 14 plus of minus 2 minus 15 is equal to minus 3. For row F3 and column D, 8 plus of minus 2 minus 9 is equal to minus 3. For row F3 and column E, 0 plus of minus 2 minus 0 is equal to minus 2. Since all the values in the occupied cells are either negative or 0, the initial basic feasible solution is the optimum solution. So therefore, the total optimum cost is 790. Note that in this problem, the unoccupied cells does not provide you any positive numbers. So there was no need for applying modified distribution method to optimize, since we already got the optimum cost as rupees 790. I hope that you enjoyed this video. See you again in the next video with another type of problem. Thank you.